Hello, everyone, and welcome to How It Works, the channel that makes complexity simple. We take everyday questions and turn them into clear, visual explanations. Curious minds are always welcome, so don't forget to subscribe, and explore with us. How fire works. A complete explanation. Fire is one of the oldest and most fascinating phenomena known to humankind. Although it has accompanied us since ancient times, whether for heating, cooking, or lighting, few people truly understand what fire is and how it actually works. Contrary to appearances, fire is not an object or a substance that we can touch. It is, in fact, a chemical reaction, more specifically, a combustion reaction. This reaction occurs when a material combines with oxygen in the air and releases energy in the form of heat, light, and gases. For fire to exist, three essential conditions must be met simultaneously. These form what is known as the fire triangle: fuel, oxygen, and heat. Fuel can be any flammable material, such as wood, paper, or gasoline, while oxygen comes from the surrounding air. If the temperature becomes high enough, the fuel begins to release flammable vapors, which, when mixed with oxygen, can trigger the reaction. If any one of these three elements is missing, fire cannot exist or will extinguish immediately. The reaction begins when the temperature reaches a critical level known as the ignition point. At this point, the atoms in the vapor start reacting with oxygen. Chemical bonds break and reform, and the resulting energy is suddenly released. That's how fire is created. To better understand the chemistry behind fire, let's look at a simple chemical equation. In the case of methane, that's CH4, a common flammable gas. The reaction with oxygen, written as O2, looks like this. One molecule of methane reacts with two molecules of oxygen, producing carbon dioxide, water vapor, and energy. This equation represents complete combustion, where methane and oxygen react to form carbon dioxide and water vapor, while releasing heat and light. Similar reactions occur with other fuels, such as wood or gasoline, though the molecular formulas vary. The flame we see is merely a visual effect of this process. It consists of hot incandescent gases that emit light. The color of a flame varies depending on the temperature and the presence of carbon particles. Blue for very hot, complete combustion. Orange or yellow for incomplete combustion. Once fire is started, it sustains itself. The heat produced by the reaction is enough to keep the temperature above the ignition point, as long as oxygen and fuel are available. That's why blowing on a candle can put it out. We reduce the oxygen or cool the area. Similarly, water extinguishes fire by lowering the temperature below the ignition point and covering the fuel, thereby interrupting the reaction. Fire produces heat and light because, during the chemical reaction, new molecules form and the energy released is transformed into motion and light, a phenomenon known as incandescence. So, fire isn't magic, it's pure science. It is a perfect result of a simple yet spectacular chemical reaction that has forever changed human life. By understanding how fire works, we not only learn how to use it more efficiently, but also to respect the power it holds. Once initiated, fire can spread rapidly, especially if surrounding materials are dry and combustible. The heat it generates preheats nearby fuel, bringing it closer to its ignition point. This is why fires can travel across forests or buildings through a chain reaction where each new ignition releases more heat, which in turn ignites the next layer of fuel. This propagation continues as long as the fire triangle remains intact in the new location. Combustion doesn't always look the same. There are different types of burning, such as smoldering, where fuel burns slowly without a visible flame, or flash combustion, where reactions happen explosively. The availability of oxygen plays a major role in well-ventilated environments. Combustion is more efficient and produces less smoke. In low-oxygen environments, incomplete combustion leads to more pollutants like carbon monoxide, along with visible soot. We hope this breakdown helped you better understand what fire really is and how it works, from the chemistry behind the flames to conditions that make fire possible. If you found this video helpful, informative, or even just a bit fascinating, thanks for watching How It Works, where we make sense of the world, one topic at a time. If you enjoyed this video, don't forget to subscribe, and share it with other curious minds. See you in the next one.